Hello everyone, my name is Bhanita working as an assistant professor in the Department of Pharmaceutical Sciences in University of Science and Technology, Meghalaya. And today I'm going to give a presentation on elimination reaction. So elimination reaction, it is a topic that included in BPharm second semester syllabus for the subject of Pharmaceutical Organic Chemistry 1. And this is a very important subject for all the BPharm second semester student. So let's start the presentation. Elimination reaction. So in the name itself it says it elimination. So elimination means removal of something. So since it is a reaction, definitely removal of molecule will happen. So as a definition we can say that elimination reaction is a type of organic reaction in which the substituents are removed from the molecule either in one or two-step mechanism. Very simple definition from the definition itself, it's saying that the removal of substituents will happen from the molecule either in one or two-step mechanism. So elimination reaction are basically of two types, that is E1 and E2 reaction. So E1 reaction stands for unimolecular elimination reaction and E2 stands for bimolecular elimination reaction. Now we'll start E1 and E2 reaction. So let's first start with E1 reaction. So E1 reaction, it stands for unimolecular elimination reaction, where one molecules get reacted at one time, and that is the reason why it is named as unimolecular, because one molecule will react at one time. So this E1 reaction is basically of two-step mechanism. So in the first step we will form one carbocation, and in the second step the molecule gets reacted and it forms an alkene. So the product of the E1 elimination reaction is an alkene. So let's check its mechanism for better understanding. Yes, so step 1 and step 2, I already told that E1 elimination reaction consists of two-step mechanism. So in the first step, we take one organic compound that is attached with an substituent S1. I have denoted S1 as the first substituent. And in the presence of potassium hydroxide, it reacted and it formed a carbocation. So carbocation means the carbon atoms which will means the organic compound which will carry a carbon having a positive charge, that is a carbocation. Cation means positive charge. So how this positive charge form? Because the S1 substituent, it try to eliminate from the organic compound, and when the S1 substituent will try to eliminate from the organic compound, it will definitely form a carbocation, and since this is cation, it will definitely carry a positive charge. Then the next step is the carbocation is attacked by the another substituent S2. So the S2 is the another substituent that will try to react the carbocation, and ultimately it will take one of its hydrogen atom from the carbocation and it will again convert as an alkene. So this is the very important mechanism, and very I think clearly we understood this, because very simple reaction. In the first step, carbocation form because the S1 substituent will try to eliminate from the carbocation, and in the second step the same carbocation will attacked by another substituent. So the another substituent will take one of its hydrogen, and when one of its hydrogen will remove from the carbocation, it will form an alkene. So double bonded compound are always named as alkene. Now let's check E2 reaction. So E2 reaction stands for bimolecular elimination reaction. Just like E1 is unimolecular, E2 is bimolecular. So why E2 is bimolecular elimination reaction? Because in this reaction, two molecules will react at a same time, and it will consist of a single step reaction. So E2, in the E2 reaction, it says that two molecules will try to react at the same time in a single step. So in E1, the substituents will try to attack or will try to leave from the organic compound in two steps, but in E2 it will try to react in one step. So that's why it is named as bimolecular elimination reaction. Now let's check its mechanism. It's very simple. So there is one compound, organic compound, where the S1 substituent is attached. So from the other side, you have seen that the S2 substituent is also attacking the organic compound. So what will happen? The same time, the S1 substituent will try to eliminate from this organic compound, and at the same time, the S2 substituent will try to take one of its hydrogen atom, and ultimately it will form an alkene with some byproducts. So from these two steps we can clearly say that the product of the elimination reaction is definitely an alkene. So in E1 we have formed the alkene in 2 steps, and in E2 we have formed the alkene in 1 step. So in E1 we have formed one carbocation in the first step, and in the second step the carbocation is attacked by another substituent, and then we finally got our alkene. But in E2 there is only one step where two substituents react at the same time. So one substituent will eliminate from the organic compound and the another substituent will attack the organic compound. So ultimately they formed an alkene. So I hope this mechanism you understood very nicely, and this is a very simple reaction but very important reaction for organic chemistry, and its mechanism is also very simple. Now let's check the difference between E1 and E2 reaction. So there are lots of differences between E1 and E2 reaction. So from there I have point out some very simple differences which we already noticed in their mechanism. So the first difference is that E1 stands for unimolecular elimination reaction, but E2 reaction stands for bimolecular elimination reaction. So I have already told that why E1 is unimolecular, because one molecule react at one time. That is why it is named as unimolecular elimination reaction. And why E2 is bimolecular elimination reaction? Because two molecules react at the same time in its single step mechanism. That's why E2 is bimolecular elimination reaction. Then the next point is E1 has double step reaction and E2 is a single step reaction. So from the mechanism only it has been clearly visible that E1 consists of two steps for forming an alkene and E2 consists of only one step for forming an alkene. Then the next point is one molecule reacts at one time. But in E2 reaction, two molecules get reacted at the same time. So in E1 reaction, it is clearly visible that in the first step, the first substituent eliminate from the organic compound, it form a carbocation, and in the second step, the another substituent attack the carbocation. So it has been clearly visible that one molecule react at one time in single step. But in E2 reaction, both the two substituent will try to attack or eliminate from the organic compound. So definitely we can say that two molecules try to react to the organic compound at the same time. That is why E2 is bimolecular and E1 is unimolecular, which I already discussed. Then the next point is carbocation is formed as an intermediate compound, but in E2 reaction no intermediate compound is formed. Yes, definitely we have already seen that in E1 reaction we formed one carbocation in the first step, but in E2 reaction there is no formation of any intermediate. We directly the substituent attack the organic compound and it formed the alkene. But in E1 first we form the carbocation. How we form the carbocation? We eliminate the substituent from the organic compound and then we form the carbocation, and then carbocation will again react with another substituent and then it form the alkene. So definitely in E1 reaction we got one intermediate, that is the carbocation, and in E2 reaction there is no intermediate compound formed because it is a only single step mechanism. So these are the very interesting and simple differences between E1 and E2 reaction. So I hope you all understood this very nicely. Then the next topic is organic structures and their uses. So there are lots of organic compounds that are listed in the syllabus of BPharm second semester. So these compounds are very important, and as a BPharm second semester student you should learn their structure and their very simple uses. So let's start with the compounds. The first compound is ethyl chloride. The structure is given of the ethyl chloride. So if you have studied the nomenclature, you will definitely know how to name the compound and how to draw the compound. Then its uses. So ethyl chloride is used as a chemical intermediate in solvent, aerosol and anesthesia. And then its next use is it is used as a medication to prevent pain caused by injections and minor surgical procedures. So ethyl chloride have very important uses since it is used as a solvent, and then it is also used as a medication for removing the pain during our surgical procedures. So definitely ethyl chloride has very important uses. Then the next is iodoform. The structure is given of iodoform. Then its uses are like, on small scale iodoform is used as a disinfectant. Then second use is it is also used for sterilizing instruments before surgery. So iodoform, definitely it is used as a disinfectant, and also it is used for sterilization of instruments before surgery. Definitely a very important uses of iodoform. Then the next is chloroform. So the uses of chloroform are like, it is used as a solvent, a substance which helps other substances to dissolve, and it is also used for purification of some antibiotics. So chloroform is a very basic solvent that we use in our laboratory in day-to-day purpose. So structure is also given and its important uses are also listed here. Then the next compound is trichloroethylene. So the structure is given of trichloroethylene. Then its uses, so it is used as an adhesives, paint removers. Then it has also been used to clean kerosene fueled rocket engines. Then the next is tetrachloroethylene. So tetrachloroethylene, the structure is given, and then its uses are like, tetrachloroethylene is used as a dry cleaning agent and metal degreasing solvent. And then the next use is it is used as an anthelmintic for hookworm infection. Very important uses of tetrachloroethylene, we all should know it. Then the next compound is dichloromethane. So dichloromethane structure is given and its uses are like, it is used in aerosol formulation. Then it is used as a solvent in manufacturing of pharmaceutical product. Definitely a very important use of dichloromethane. It is very important. It has very important use in aerosol formulation, and also it is used in manufacturing of pharmaceutical products. Then the last compound is tetrachloromethane. So this is the structure of tetrachloromethane that is given here, and its uses are like, it is also known as carbon tetrachloride. So carbon tetrachloride, it was used to produce the chlorofluorocarbon refrigerant, and it is useful solvent for halogenation. So yes, definitely a very important use of tetrachloromethane. So this is all about the presentation. I hope you all understood. So elimination reaction along with this compound is a very important topic that is present in the syllabus of BPharm second semester in the subject of pharmaceutical organic chemistry 1. So I hope you all will understood. And yes, it is a very simple reaction, elimination reaction, and I have very simply described its mechanism also. And again, these compounds are also very important. As a BPharm second sem student, you should know its structure and its uses. So this is the end of the presentation. Thank you.